So last time we'd gotten together, uh, Ryan Turlip, you had asked about 18, and we were working our way down. And I think we got past these, which I think, are pretty straightforward, but we stopped around like 12, 13, 14. I don't remember exactly which number we stopped on. But um, so I'll ask you, are all of these clear to you now? The 12, 13, 14?
Yeah,
Ryan?
those were the ones I actually asked about, and I'm
Okay.
good on those now.
Okay. And the numbers 14 and 15, just for general reference, these are important questions for us because, in the main lecture, we said, well, we're focused on demonstrating the first fundamental welfare theorem. And basically what 14 and 15 do for us is they show us that there's going to be, well, actually 13 too, that there's going to be a peak in terms of total surplus at the market equilibrium. So look at number 13 and look at the hints, 490. And then this is, if we go a little bit bigger, 480, total surplus goes down. And now look, if we produce a little bit less than the equilibrium, 480, total surplus goes down. So hopefully, in addition to solving the problems, you can see that there's a pattern in the problems, and the pattern's telling you that competitive markets, and we're looking at the competitive market equilibrium, right? So, this is a basic demand and supply system, that competitive markets are efficient. Competitive markets do maximize total surplus. And if you put any demand and supply system up here, with a few like weird exceptions maybe, and went through exactly the same steps, you would get exactly the same pattern. I say for a few exceptions because I'm really talking about things outside the norm, things that wouldn't really be a standard competitive market. But if you've got a system where the demand curve obeys the law of demand, so you have a negative slope here, and the supply curve obeys the law of supply, it's got upward sloping there, then yeah, you'll see that total surplus is at a maximum at the market equilibrium. So then we have these related concepts of deadweight loss, right? And change in total surplus. And I posted some lectures for you guys, for you all to watch in place of the main lecture today. But here the answers may be a little bit subtle, but the main issue here is that deadweight loss is the change in total surplus, okay? If we were to calculate it, right? This is from producing 4 units of output. So to calculate deadweight loss, we have to calculate first total surplus for the market, and then we have to calculate total surplus for exactly 4 units and take the difference between the two, and we'd end up getting that the total surplus at 4 units is less than the total surplus at the market. And we know that because the first fundamental welfare theorem tells us that the market equilibrium total surplus has to be bigger than any other. So the only thing that could possibly happen is if it turned out that 4 units was exactly the market equilibrium quantity, then this could be 0. But otherwise, there's always going to be a deadweight loss, which is a smaller surplus, but by how much the surplus is smaller, because it tells us how much welfare we're giving up by producing something other than the market equilibrium quantity. But the issue here is that the change in total surplus, notice that's a negative answer, and this is a positive answer, and they're exactly the same. Okay, and so there it's because just by definition, deadweight loss is an absolute value. Okay, so you have to know that deadweight loss is an absolute value to answer this question. Okay, and then I forget who asked about question 18, but so let's see, this one's what's the change in total surplus. This is exactly the same thing as number 17, right? The only difference is it's just like extra practice. It's a different set of equations, and this one is 2 extra practice. It turns out, oh yeah, so this is a little bit different. Change in total surplus, and then change in and then how much deadweight loss again. So these 2 are the same. Change in total surplus and deadweight loss. Okay. So without solving all of the problems, I've walked you all through them now, and I'll ask. So we do have another assignment coming up, but you'll have completed this one now. Do you have any questions about any of these that we didn't explicitly solve? We can focus on those, or you know, I can just move us on to something else. So does anybody have a question?
Well, my question isn't particularly like about this homework, but I was just like looking through the syllabus and everything. And the next thing isn't due until September 20th for the equilibrium homework, right?
So Wombly.
Yeah.
Equilibrium homework. I'm a little bit.
Maybe that's a discussion, but when I just go on there, it says the next assignment up is until the 20th. So I'm just kind of confused about that.
Okay. So you're asking about, let me see if I can. I'm gonna stop sharing this and make sure. Okay. Oh, somebody has roosters.
Yeah, those are mine actually, sorry.
Okay, so this counts as the general questions, which I wish you would have asked in the beginning. So I'm gonna so now we're focusing on 1920, the first half of the class, do 19, second half 20, and then we'll come back in about, I'll give you 7 minutes, because these are going to be a little bit longer problems, and then we'll talk about the answers. Does everybody understand? If you do, go ahead and give me like a thumbs up. And okay. Okay. All right. So I'll see you all in 7 minutes and ask you about your answers. Okay. So I'm going to go ahead and grab this question. And And I'm going to stop sharing here. And let's go to the whiteboard. And paste it in. Okay. Okay. So let's see. I guess we'll start with the Emily's. Emily Cobian, how are you doing this morning?
Good morning. I'm doing okay.
Okay. So Emily, so question 19. What's your suggestion for how to go about solving this?
What I did was I set the equations equal to each other and solved for Q. And then
Okay.
once I did that and got the answer for both equations, then I used like the answers and used area of a triangle.
Okay.
Oh.
So you get the change in total surplus, but it sounds like, so first, your first step was you're going to calculate the total surplus, and I'm going to make this, hopefully this notation makes sense to you, because if you think about it, it's fine.
Yeah.
Total surplus is a function of the quantity produced, right?
Yes.
So you're calculating total surplus, and you remember the star is for the equilibrium quantity, right?
Yeah.
So the first thing you're going to do is calculate the total surplus at the equilibrium quantity. And then your second step would be total surplus of Q is equal to 4 units. So we can think about how we want to do that as notation, but I'll kind of do it this way. I'm just doing it. I would normally just put in 4 here, but I want to make sure everybody understands that it's Q that's equal to 4. So
okay.
I'm trying.
I wasn't too sure. I was like, do I have to solve for total surplus and then add 4 and then subtract each other to see the difference, or is it just?
Well, yeah. This is So notice up here the question. It says, what is the change in total surplus compared to the market level output? So that's compared to Q star. And so we could change this question a little bit, and so let's see, let me select this. I could put in here Q star, and over here I can put Q equal to 4 units of output. Do you see? I don't know if that helps clarify, but that's what the question's asking.
Okay.
And then the last step for us is always going to be, it's the changes compared to, so we're going to take the difference between these two. So sometimes in math and science, they use a D to mean the change in. You might have seen that if you've taken a calculus class. So we're calculating the change. So we're going to do TS of, and hopefully my notation now is clear, minus TS of Q star. So it's the change from this. This is where we're beginning.
Yeah.
And this is where we're ending. And the change is the difference between the two.
Okay.
Right. In the chat, Keontae asked D for delta.
Yeah. Not the coronavirus variant, but for D is for delta. Yeah. So, and then this would be our final answer. Okay, so you were giving a suggestion, at least as I understood so far. Your first step, Emily, was basically find Q star,
Yeah.
which makes a lot of sense. And then when you said the triangle thing, you were suggesting that's how we would calculate total surplus.
Yeah. So
From
that where I did extra work.
No, that's fine. I mean, that's what we've been doing. That's what like I would have done,
Okay.
right?
Mhm.
But I only have one step that I would suggest first, which for almost all of these, and can you guess what it is?
Plug 4 in.
No.
No. Oh, okay.
So I'm talking about before you do any of this other stuff. I can't plug 4 into, what do I plug 4 into anything right now? I don't know. But I would suggest to graph it.
Okay.
Because if I don't graph, I mean, for me, the graphing part is like a memory device to help me keep track of everything, right? Because if I don't graph it, then I know that chances are I'll get confused at some point. And I also will say, remember that it's good practice, because on the exams at the end, I always have graphing questions, and they make up about 15% of the grade of the exam. So it's significant, right? So you could get 100% on everything else and graph nothing, and the highest grade you could get then is a B, right? So anyway, graphing is part of our standard toolkit for economists. It's how we communicate with each other, people outside the discipline. So, but normally when I graph these things, I just kind of sketch a graph of, the things that I need to know in order to answer the problem. And so your suggestion of the triangle, is exactly right on, because I got to know where this triangle is and what the values are. So what should I put here then, Emily? I'll just continue on with you for a minute. So what's the vertical intercept here for the demand curve?
Would it be 3?
Well, it's the demand curve, right?
Oh, it's the demand curve. Yeah, so it'd be 58, right?
Okay, yeah, so 58 there. And then the vertical intercept for the supply curve is going to be
3.
Okay, yeah. So does that make sense? So that point, so these points, right? And this is going to be one of our sides of the triangle, right? So this is going to be important for us. And then, so then you said that you calculated the other point we need to know for our triangle is we need to know Q star, right? So you said you calculated Q star, and what did you get?
7.9, roughly.
Okay. Well, remember, we want to be as precise, so I would say like 2 digits, right?
Okay. Then it'd
So
be 7.85.
7.85. Okay. So does everybody agree with Emily? Does anybody disagree with Emily? I haven't calculated it myself, but it's going to be 55 divided by 7. 7 times 7 is 49. So that looks about right to me. Yeah, because it's sometimes 8 is 56. So that looks good. Does anybody disagree, or does anybody have a question about what Emily did? Okay. So, okay. So I think that looks good. And so then to calculate the area of the triangle that you're talking about, right? So you go ahead, this is our base, right? And then the height of the triangle is going to be the distance between the base and that vertex, right? If this line was straight, I'll try to make it a little bit straighter, right? So and we can measure that along the axis here. Those are the same distances, right?
Yeah.
So what did you get then for the area of the triangle?
With that, I think I might have did it wrong. Just because once I got Q star, I plugged that into place for Q for each equation.
Oh, okay. Well, then you should have gotten the same value, which is the price,
Oh, okay. Okay.
right? Because you put if I put Q back in here, that gives me a value for P,
Yeah.
right?
Yeah.
So and we don't even really need P for anything, right?
Mhm.
So yeah, put in a Q, get out a P. So do you need help, or do you want to, now that we've kind of drawn things out? And also, I don't know if this helps you or not. Now that we've drawn it out, are you a little bit clearer about, okay, this is what I got to do next, or are you still confused?
I think I'm good.
Okay.
Yeah. But if
So then what should we do then?
maybe I'm not clear. Yeah, no, this is where I do need help. After like seeing the graph, I'm like looking at my work and I'm like, I think I did something wrong. So.
Well, yeah, so right, we're just calculating the area of this triangle, right?
Yeah.
And do you remember the formula for the area of a triangle, right?
Yeah.
What is it?
1/2 BH.
Yeah. So
Turn on your camera.
0.5.
I don't know if you can in here.
But they're gonna see you. Okay, I'm on.
You're in the
Okay, are we good?
It's a tank top.
Yeah.
Even like a t-shirt might have been a little bit better. It's okay.
Okay,
I
so
don't need your video.
Emily, are we good?
Yeah.
Okay. So it's 1/2 base times height, right? And so we just have to plug in the numbers, right?
Yeah.
So what's our base?
Thank you for helping me with it.
Mhm.
I'm gonna starve when I get out.
You gonna what?
I'm gonna starve when I get out.
So what's our base?
I'm gonna be honest. I'm not too sure.
Well, we pointed it out, right? It's along here. Can you see that distance?
Oh,
I can.
okay. Then someone just helped me on the chat. Thank you, Brian. 55.
Yeah, but do you see why?
Yeah, I do. I was thinking that, but I wasn't sure if I was right. What Brian just suggested. I don't know if you can see that, Professor. But
Well, I mean, I could see if I was going to look at the chat, but I have the chat closely. I have all this stuff open in my thing. But do you get it? Like, there's
yeah,
a
I
triangle
do.
right
Yeah,
there,
yeah,
and
yeah.
there's
I
the
just
base.
wasn't. Yeah, I just wasn't certain in like my own thought, so that's why I was like a little.
Yeah.
Yeah.
And then what about the height?
The height would be the difference between Q star and, or it would be 7.8, right?
Yeah.
Yeah.
It's just
Okay.
that distance.
Yeah.
Okay. So 7.85, right? And so plug it into your calculator, and what do you get? I might go ahead and get rid of that.
215.875.
Okay, so you see 215.875. Okay, So yeah, so the area of this triangle, the amount of total surplus created by producing 7.85 units is 215.875. I'm assuming that's correct. I mean, I can kind of guess that it looks about right. But anyway, does anybody disagree? I don't know if you all calculated the answer too. But now we kind of have our next step, which is we have to calculate total surplus at only 4 units. So I'm just gonna stick with you for one more minute here to clarify, Emily. But can you see that like 4 units worth of output, and I'm gonna get rid of that right up here. 4 units worth of output is going to be to the left of Q star. So it's going to be like about right here. Can you see that, Emily?
Yeah.
And so this would be, and I guess just to kind of clean up the diagram a little bit. See if I can select this and get rid of that too. So let's put it on the, that's 4 units of output. Okay. So now our total surplus, right, is we only get the surplus from, I'm going to move that over there. Now we're only going to get the surplus from the first 4 units, right, Emily?
Yeah.
So now it's just going to be, I'm doing one base, there's another base, right? It's just going to be the area of this trapezoid here, right? So we're cutting off the triangle and we only have the total surplus from the first 4 units. Does that make sense?
Yeah.
Okay, so now to calculate this total surplus of Q is equal to 4 units, we have to calculate the area of the trapezoid.
Yeah.
Okay. So the one base, can you see what's this base going to be?
55.
Yeah, 55, right? And do you remember the formula for calculating the area of a trapezoid?
Off the top of my head, no, but let me look at my.
Well, okay, well, memorize this because you're going to use it in the course a lot.
Yeah.
B1 plus B2, those are the 2 distances for the bases. Okay, times 0.5. It's a lot like the area of a triangle.
Yeah.
Okay, times the height. Okay, you'll notice for the area of the triangle, right, the only difference is that if B1 was equal to B2, it would, anyway, the bases are the same. It's kind of weird. One base is 0 and the other base is the base of the triangle. But yeah, anyway. So the only difference here is the way the bases are, and that's because in the case of triangle, the one base that's common is the same, and B2 is 0 for a triangle because it's a point. Okay, but anyway, hopefully you can remember this because you'll use it a lot.
Yeah.
So yeah, we have B1, which is 55, and then plus, but we don't know B2 yet. So I'll just put in B2. And we also, we know 0.5, but we haven't really identified the height. But I will say one thing about the height really briefly, just to clarify. the height is going to be the distance between the bases. So it's going to be that distance there, which can be measured along the horizontal axis here. Okay. So can you tell me what the height is then?
4.
Yeah. So the height is 4. Okay. So that's easy. So the only thing we don't have is we don't have B2. Okay. But let's see. Maybe I'm trying to pick good colors. I guess I'll use brown. Okay. Right. We can find those, but we have to find the value of each of these functions. Basically the corresponding price on the demand curve and then the price on the supply curve. And then we can see the two values that mark out the distance for the second base. So can you see how we would do that? Does that make sense? Or you?
Yeah. A little.
Okay. So does anybody, well, let's go ahead and move on to somebody else then here. Let's see. How about on Tweet? How are you doing this morning?
I'm good, and you?
Pretty good, pretty good. So do you want to help us finish up here? We need these two values.
That TX4 minus TX Q.
Well, I need values. You're gonna give me some numbers.
Coming. Is the top one? So you look for the question marks?
Well, yeah, unless you have another way of calculating the area, which
No.
we're trying to calculate the area of the trapezoid right now.
Okay. So I just joined, so I was like, oh, confused. But let me do the calculation.
Okay, well, let's see if I can phone a friend then see if somebody else. So I'm trying to ask people who I think might benefit more from the discussion than other folks, because Andrew Lee, how are you doing this morning?
Fantastic.
And do you want to help us out, Andrew? Do you have any questions?
Well, I did the integral, but the first one I believe is 38, and the second one is 11.
Yeah, and it's just because you take 4 and you plug it in.
Yep.
So taking 4, putting it in for the demand equation to get the value of demand. So that's going to be 58 minus 5 times 4. That's 58 minus 20, because 5 times 4 is 20, and you get 38. So I agree with you. That's 38. And then you do the same thing. 4 goes in to the supply equation to the height of the supply. 2 times 4 is 8 plus 3 gives us out a value of 11.
Yeah.
So
for
I agree.
Like
so this is let's do 38. We'll just do it, in pieces in case people are curious. And then then you were gonna say, go ahead for the second base.
27.
Yeah, so the second base, right, is just the distance between those two values. So I'll just be unnecessarily thorough. So we're gonna do 38 minus 11, which is gonna give us 27, right?
Yeah.
So then we'll get is equal to 55 plus 27. 27 times 0.5 times 4. And so final answer there is what?
Oh, times 4. Oops. It should be 164.
Yeah, so 1/2 times 4 is 2, right? And so it's going to be 55 plus 27. That's going to be 81 times 2. And you said it's 162?
Yes.
Right. So I agree, 162. Now, our final step, right, is we have to take the difference between these two values. So we're going to do 162 minus, because we started out at the equilibrium level of total surplus, which is 215, 0.785, right?
Actually, Professor, I think it's 164. I'm sorry.
Oh, is it 164? Okay,
Yeah.
I was just doing it. Yeah, you're right, because that's
I
12.
thought I was
Right.
wrong.
Yeah. No. It's because I was doing it in my head, and I was being too quick. I'm getting us a little more space here. Okay. And okay, so what's our final answer?
52.072.
Okay, and I corrected that to
But
164.
that's what the integral. Oh,
Okay, well,
sorry,
it
I'm
should
so
be the
sorry.
same, right? If you calculated your integral correctly.
Yeah. Negative 51.785.
Negative 51.785. Okay. So this is saying by reducing our output from 7.85 to 4, we lost, right? Because we have a negative there. We lost 51.785. And remember, this is dollars worth of total surplus. Okay, so I'll ask you all, do you all have any question for me about this one? Any questions? Any questions? No questions. Okay, well, I think maybe there was a little calculation error because I have to have my calculator to do this. And okay. Well, Ignatium says this. Okay. I wouldn't be bothered about that. It's like within rounding error. So I can show you all. So stop share. And then we go back to Ignatium, share. And if you all are ever curious, so we said minus 51.785, right, Andrew? Andrew?
Yes.
Are you there? Can you see minus 51.7?
Yes.
That's what we said. Now, if I hit submit, I get the yay. And that means that it's accepting the answer. It's scoring it correctly, right? So it seems we're a little bit off. I don't know why we're a little bit off. I'd have to go back and check the calculations, but I'm not worried about it because we're close enough. You see what I'm saying? For rounding error.
Professor,
Yep.
I don't think my Ignithium has the answer entry option.
Well, okay, we'll check it out at the end. Okay.
Yeah, sorry.
Um, okay. Was somebody else going to ask a question?
Professor Wise, your answer was wrong, but Initium say is correct.
Okay. Yeah. So Hung, do you know what rounding error is?
Oh, so it's counting like rounding is accepted.
Yeah. Again, there's a margin of error. It's a very small percentage of the answer, but because we're dealing with decimals here, we can be off a little bit. And so if you're checking answers in Ignithium and you're wondering, is my answer close enough? Because you can see the answer here, right?
Yes.
Then you actually put it in the answer box and hit submit. And if you get this answer, then you're correct. It'll say yay, right?
Oh,
But like, let's say I put minus 70 here and hit submit. Wrong,
Okay.
right?
So the answer doesn't have to be like exactly as the hint base is can close.
It has
the-
to. It has to be very close, but not
Okay.
exact.
Like if I'm putting like minus 52.11 is
Yeah, it'll
Also-
probably. Yeah, that's close enough. I'm pretty sure.
okay.
See, it says yay.
Yeah, okay.
Okay, so you should play with it. That's why it's on open on infinite practice, so you can play with it and get comfortable. Okay, so I'm gonna stop sharing there. I'm gonna go back to the whiteboard, and now you all probably remember that the next question 20 is the same, but it asks for deadweight loss. So let's finish this up and I'll do Emily Harrison. How are you doing, Emily?
I'm good. How are you?
Pretty good. So how would things be different if we were calculating the deadweight loss?
So the only thing that I can see that I really did different was that when we got the trapezoid in the triangle area, I minus the trapezoid from the triangle.
Okay, and can you tell me why you did that?
Because it said the change, and so that's kind of it's getting rid of the overlapping area pretty much. So it's the area that's above the that's like it's the area that's missing in the unit count essentially. That's why I did that.
Okay.
That makes sense.
So yeah. So I think your logic is that, and correct me if I'm wrong, is that you're just basically calculating the area of this triangle because you're saying that's what's missing. And yeah, that is what we call the deadweight loss triangle. The only thing I was gonna hope, you know, the connection would be is that deadweight loss is, and I'll write it up here and see if this makes sense to you. The definition for deadweight loss, let me go write it down. I'm looking for an area because I got my screen all. Okay, let's try to move this up a little bit. Okay. So the definition of deadweight loss is deadweight loss is equal to the absolute value of the change in total surplus. That's the definition. So you're okay to identify it as that area. I just want to make sure that you understand the change in total surplus. Basically, it ends up being negative because we're losing total surplus, right? As we reduce the output. The first fundamental welfare theorem says we get the most total surplus at Q star, pick another quantity, and total surplus is going to go down, right? And so the change, if you're going down, has to be negative. right? But deadweight loss is just a concept that's based on fundamental value. I mean, on an absolute value, and you know why? It's because of the language, right? It's the loss thing, right? So if I ask you how much money did you lose, you're gonna say, oh, I lost my wallet and it had $200 in it. I lost $200, right? You're not gonna say negative $200, right?
Right.
Because the loss is already taken care of the minus sign. Does that make sense?
Yeah, that makes perfect sense, actually. Thank you.
Yeah. So it's okay to identify it as an area of this triangle, and oftentimes we do, and in texts we do, but when you're talking about measuring efficiency overall, and that when you move away from equilibrium, you're going to have efficiency losses, it's a good idea to kind of differentiate. Well, how much did your total surplus change? Well, it changed by negative 52. What was your loss? Oh, it was 52. That happens a lot in economics. So that's why the questions are here, is just to make sure people are connecting total surplus as a measure. And the one thing that happens a little bit that might hobble some people's development as economists is they get stuck on thinking about deadweight loss, and they never really connect deadweight loss to the overall measure of total surplus, and so hopefully this will reinforce that they're kindred concepts, very closely related to each other, except for a minus sign, basically. So one is the twin of the other. Okay, so, and then obviously I'll just show you all really quickly. And so when you did that, Emily Harrison, what value did you get?
I did get the 52.15.
Okay, so I will go, because let's see, I'm curious, because sometimes these calculations turn out to be a little bit different. So if you do it on your calculator, so it's going to be the base of the deadweight loss triangle is 27, right? And then the height is 7.85 minus 4, so it should be 3.85. So if you,
there's a difference in my stuff. I got, because it was 7.857, I think. So I just made it.
Okay.
Yeah. And then
So
that's something that's different.
And okay, so I never calculated the equilibrium myself. So you said it's 7.857.
Yeah.
Okay, so let's do that. Yeah. So if you do 27 times 0.5 times 3.857, what do you get for a value in your calculator?
I'm sorry, you said 27 times.
Yeah, so we're just calculating the deadweight loss triangle is equal to, right, the base is 38 minus 11, that's 27, times 0.5 times, I'll just be unnecessarily verbose, right?
Right.
So that's 27 times 0.5 times 3.857. And what value do you get?
52.0695. But that'd be
5. Okay.
Yeah.
I mean, I haven't put it in my calculator. I'm just relying on you. But I'm just doing this because I want to, okay, so let me do the stop share, and then I'll do the share screen. I'll go back to Ignition. And so we're down here, right?
Mhm.
And I'll go boom. And see, I just wanted to show you that we're still within rounding error. Is that okay?
Yeah, that's fine.
Okay. So anyway, I normally recommend students to do like 2-digit precision, right? So round to 2 significant digits in the decimal places. And that'll almost always give you the right answer. I had a student, and this is just an aside for you. If you are doing this and you ever get to a place where you're like, the rounding error is off, rule of thumb is this: the smaller the numbers involved, the more rounding error becomes an issue. So if it's a number that's less than 2, then being off by a little percentage can really, make the precision very small. If you think of like 3% of 2 is a much smaller number than like 3% of 50, right? So if the numbers get small, you have to be more precise. I had one student who was very dedicated about a year and a half ago, and she went through and did all of the problems multiple times. And she said that she never, ever had a rounding error issue when she used 4 digits of precision. So not like 52.06, but like how you have the 50.0695, that she never got the wrong answer from Ignition if she carried around 4 digits. In most cases, that isn't really necessary, but as you practice, if you end up hitting a rounding error issue, then you want to try to increase your precision and see if it goes away. Okay. All right. So my dogs are barking and my doorbell is ringing. So I'm gonna let you all go. You have the lectures to watch for the main lecture. And do you guys have any questions for me? Quickly.
Yeah, Professor, I'm sorry. So I have a question. You know how for 19 and 20, the answer transfer, instead of doing, the same